One trick for solving algebraic equations that is sometimes helpful is to do a substitution. You just invent a new variable that depends on the previous variables, and then use that to rewrite the equation. And hopefully your new equation after substituting is simpler than your old equation. Well, we can do the same thing with differential equations, although we will have to be careful about translating the old equation into the new equation when we do the substitution. Let me show you what I mean. So the idea is, if we have some idea for a new variable, we're going to call our new variable u, right? We might just invent a new variable u, and it could be some combination of x and y. So g is just the function g is just indicating that we're somehow writing down a formula that involves x and y. Another way to do a substitution is, instead of saying your new variable is a function of your old variable, you could have your old variable y in terms of your new variable u. So we might write it like this. So if we have this differential equation, dy dx is some combination of x and y, and we want to introduce our new variable, say y is some combination of x and u, how can we do that? Well, right, everywhere we see a y, we need to use our substitution equation to turn it into u's. And one place to do that is right here, right? We're just going to put our new function, or our new combination of x's and u's in here for y. But there's another place that y shows up in this differential equation. It's right here on the left. So we're going to have to figure out what dy dx is, and how the substitution equation, what it turns into when we take derivatives. So we're going to have to differentiate both sides here with respect to x. Now the left-hand side of our substitution equation, when we differentiate it, we just get dy dx. Right? So this is a good sign because it means whatever shows up on the right-hand side here, we're going to use it to replace dy dx over there. So what we need to do is take the derivative of this thing with respect to x. Right? But remember, since y was an unknown function of x, u is also actually an unknown function of x, and so we have to use the multivariable chain rule to take this derivative. So the multivariable chain rule says it's the derivative of g with respect to u, let's do x first, times derivative of x with respect to x plus derivative of g with respect to u times derivative of u with respect to x. Okay. Another way you might write derivative of g with respect to x is just derivative of y with respect to x, right? G is really representing y in this situation, so you might write it like that. Okay, so dy dx is the derivative of this function g, which remember, g is representing some combination of x's and u's. So take the derivative of that with respect to x, multiply by dx is 1, plus the derivative of this combination of x's and u's with respect to u, times du dx. And du dx, since it depends on x in some unknown way, we have to leave this derivative, du dx, as it stands. Right? If we have an actual substitution, so some actual formula here, the derivatives for g we can actually calculate. But the derivative for u we won't be able to calculate because we don't know what u is yet. Okay, now we can take this and put it into our differential equation. So the left-hand side of this differential equation becomes derivative of g with respect to x plus derivative of g with respect to u times du dx equals f of x comma, and then remember y is g of x comma u. Okay, So now let's take stock of what the heck this new equation is. Remember, when we have an actual substitution in mind, these two derivatives, the derivatives for g, those will be formulas. Those will be mixes of x's and u's that show up. So those aren't unknown functions. Also, if this function f, that's just representing the mix of x's and y's that was in our differential equation to begin with. So the only unknown things in this equation are this derivative, du dx, and this u right here, because remember, we don't know what the function u is. So what we have here is an equation with an unknown function, u, and its derivative. So this is a differential equation, but this differential equation has u for the unknown function instead of y. So that's why the substitution idea actually lets you turn one differential equation with the unknown function being y into a different differential equation where the unknown function is u instead. Of course, for any particular example, whether this is useful or not really depends on how or what this new equation looks like. You shouldn't memorize this equation. For any particular substitution, you'll actually just work out this substitution process and see what the new equation turns into. But the idea here is if you want to do a substitution, you can, but you have to be careful about working out the derivatives.